But we have venture capitalists sitting up here. And so the question is, why? What are you investing in manufacturing, and why is that happening? And then I thought that, in a way, that would be a good way to introduce yourselves. So let's start with you, Chetan.
So good afternoon, everyone. And we've talked about, the previous section was all about Amazon delivering you your product in an hour. So we are all about how does that product get made. So less about delivering it, but how it is made. I work for Yaskawa. I lead their development of collaborative robots. You heard about that this morning. Yaskawa as a company is a 100-year-old company. We started in mining. We made the first electric motor that got put in a coal mine. And then we realized that, hey, motors was a good business, so we started making a lot of motors. And then we realized that we need to make a robot because a robot has 6 motors. And we could easily sell 6 motors when we sold a robot. And then the robots became a big business for us. It is probably I would say, one of the largest segments. And we make industrial robots. Robots that are used to make your cars, robots that are used to make your appliances, your iPhones. That's what we do. A unique thing about Yaskawa is we work on human scale robotics with the human being at the center of our manufacturing robots. We coined the term mechatronics, and the new term for us is humatronics, which is our humans and machines combined. And collaborative robots is a big part of that, and that's what I'm here for.
Hiro, what about you?
Yes, good afternoon, everyone. This is Hiro Saijou, who is working for the CEO of the Yamaha Motor Ventures Laboratory. This is a corporate venture arm of the Yamaha Motor Corporation. Okay, I would like to make some questions to you guys. How many of you guys know Yamaha is doing a motorcycle business? Raise your hands. Great, appreciate it. How many of you guys know we are doing a marine product? It's like an outboard engine or sexy boats? Great. How many of you guys know Yamaha is doing 20 years working for the industrial automation, factory automation as an industrial robotics provider? Yes. Oh, more than expectation. That's great. And that's one of the reasons why we are starting some activity here in Silicon Valley, how we can explore future of Yamaha, not today's Yamaha. One of the symbolic project is a Motorbot. We exhibit one table in the expo area. It's a world first humanoid robot can ride a motorcycle autonomously. It's a great symbol because it's kind of the combination of the robot and the motorcycle. So based on my experience in the factory automation, it's a B2B business. And then my major client was Apple, Nokia, Samsung, Toyota, Bosch, all those manufacturers. One of the discoveries through my experience is they didn't understand what they want to have for their purpose. They are very expert. They are very experienced for the manufacturing, how they can make their manufacturing process to be better. But in terms of robotics, they are very amateur. That's why I try to make ourselves to be a service provider, solution provider, rather than just product supplier. This is the kind of the things that now more accelerated in the manufacturing process, I believe.
Patrick's an exception.
That's right. I think I'm the only venture-backed startup person on the stage. I run a company called Vail Robotics, which is a relatively new startup. We started a year ago, a little more than a year ago now. And what we do is, despite our name, Vail Robotics, we don't make robots. We make brains and eyes for robots. So what we're working to do is make big standard industrial robots collaborative. We seek to give them the perception that they need in order to be responsive to the presence of a human worker. And we use 3D time-of-flight cameras for that, but perhaps more importantly, we use our own parallel algorithms. So what we do is we build a semantic representation of everything that's going on in a manufacturing work cell. And we understand this is part of the robot. This is part of the workpiece. This is a human, here's another human, and so on. And what we then do is we tie into the controllers made by the robot manufacturers, and we override speed. And we will put the robot into a safety monitored stop when necessary so that a human worker can fluidly get right in there and interact with the robot. And you know, if you were to search on YouTube, TechCrunch published a video of our system in action some time back. We work closely with our partner Yaskawa as well, with a bigger robot than you'll see in that video. And our goal is to make factories much more flexible, much more human aware, because the best resource you can have in a factory, the most flexible, the most capable resource in durable goods assembly, for example, is a human worker. If you have a process variation that surfaces in the field, in other words, a quality problem with a new product, you have to change your manufacturing line. If everything is automated, you cannot put a human inside the cage, so you need that robot to be collaborative. And as a result, what we're doing is we're creating process step flexibility so the manufacturers can be more productive and more flexible and create the kinds of customization and the kinds of new product releases that everybody wants. So we're very excited to be here.
Great. Hi, so I'm Steve Taub. I'm a managing director with GE Ventures, which is the corporate venture capital arm of General Electric. So, you know, our job is to help keep the company on the cutting edge of innovation in a variety of sectors that are strategic to GE. Manufacturing is obviously one of those. So GE has about 400 factories and 500 warehouses around the world. We're manufacturing everything from industrial computers and light bulbs to jet engines and 200-ton locomotives and even things like radiopharmaceuticals. So we have a tremendous variety of manufacturing processes, a lot of them in very quality conscious, heavily regulated industries, a lot of them with very high-tech, complex products that we're making. And so, you know, our job as on the venture side is, you know, we're trying to help find companies that have, on the outside, that have technology and other innovations that our manufacturing people can work with to make our operations better. So that's everything from you know, robotics to 3D printers to augmented reality and systems for field workers and field service technicians and factory workers, to even things like platforms, software platforms for human capital management. So very excited to be here. Thank you.
And finally, we have Eduardo, who is not Thomas.
Yeah,
but
hello, everyone. With Omron Adept here in the US for 10 years. Well, I would you know, use a bit the story that Patrick explained before. The main trigger to Omron to enter in the robotics business was to expand our capability to give a solution to our customers that are not focusing mainly on the machine automation, but we are now embracing you know, all the handling tasks that were out of our control. So Omron is a company having, you know, sensor, vision department, motion, PLC, HMI, all those components that allow people to develop, you know, their machines. We are missing the robotics part, what we call fixed and mobile robots, which is, you know, the fixed is the more classical definition of a robot, and mobile robot, a robot that brings material from A to B. And the main trigger to us was, how do we enhance the flexibility of the line? How do we customize product for our user, basically consumer business? And we were missing that part of the solution. So the main challenge we have and we see is that using the automation product that we do have, how do we make this changeover, product changeover easy to allow the main maker to customize product? Because what we see is a strong trend in customization. So back to what Patrick said, it's really the flexibility in changing the product by minimizing the investment, our main challenge today.
current manufacturing robots can be sort of visualized as fixed, caged, and blind. And so when they talk about the revolution, what are they talking about? Are they talking about just adding vision or getting rid of conveyors and positioning systems, or what? And what are you investing in along that line?
So I think all the things you pointed out are part of the revolution. The ultimate revolution for a manufacturing robot would be to have human-like capabilities, right? We are far from there today. So a person like me that is responsible for new product development, the challenge for us is what can we do that we still consider revolutionary without having to wait 15 years or betting the whole company on a risky path that may lead to nothing in the short term. So where I feel the biggest revolution is a mobile manipulator, for example, that can go around and do some work would be excellent, but I feel that making it really productive, there's too many things in the process that this robot will not be able to do that will lead to a non-cost-effective deployment in the next 5 years also. Some applications maybe. So you go, what can we do? You know, what can we do? And if I was just talking to somebody, Sachin, who does a vision company right now, they're doing depalletizing and all sorts of each picking tasks, right? And my question was, instead of trying to perfect a robot doing something, what can you do? Can you make a robot recover from errors very easily, as a human does? So given that line of thinking, to me, a revolution would be robots that are able to intermix with humans and work alongside humans, and that humans do some productive things while the robot does some more menial things. I think this is a shorter term, next 10-year vision that we can achieve. Mobile manipulation will happen. The perception algorithms that are being developed, that'll be there. But a big barrier remains the human hand. We just are nowhere close to that in terms of robotics and the type of capabilities that offers.
Just a small interject here. One of the things that mobile robot providers are finding is there is so much market for just gophering that for the next couple of years they're just going to be supplying devices that go from point A to point B, with or without a shelf, just a platform.
Almost every single company in mobility started with mobile manipulation. They came out of research, and very soon the manipulator just disappeared. And it's for a reason.
Okay. Yes. Back to the when we see the history of the factory automation, most of the application and the robotics was driven by economical advantage, because the advanced robot has a much superior capability to manufacture that product much better than human, right? That's why it's kind of the investment and the return model. So most of our customer can expect maybe less than 5 years in the returning period. That's why the product scale and volume is one of the key factors for the customer to make automation for their process. But when we are looking at the current trend, somebody in the morning session mentioned it's from mass production to the mass customization. That means the redefinition will be required for the required robot for the factory automation. Until now, we are trying to make the robot faster, the stronger, and 24/7, all those stuff to make the bigger volume. But more flexibility or redundancy or robustness, all those factors could be more important than past. How we can redefine our robot to be meeting that kind of a new requirements, that's kind of be a part of the revolution, I believe.
Can we skip Patrick for just a second and go to the other venture capitalist here?
Sure. So we're investing in robotics for manufacturing. So, you know, a couple of the areas we've invested in are collaborative robots. So Rethink Robotics is one of our portfolio companies. You know, for folks who aren't familiar with them, you know, they are developing you know, very flexible collaborative robots that can help automate lots of tasks that were not cost effective to automate in the past with traditional fixed automation systems. You know, another example is another one of our portfolio companies, ClearPath Robotics, which is in the mobile space. So they're developing, commercializing autonomous mobile vehicles for factory and warehouse settings. And so GE is actually deploying Rethink and ClearPath's products in our factories today to help us, you know, become more efficient. And, you know, for us, it's about not just reducing the direct cost of manufacturing. It's about things like reducing the cost of quality, and in some cases reducing things like worker injuries that also impose indirect costs. So, you know, we see lots of value in continuing to deploy automation within our operations. But, you know, we're also using robotics for increasingly for tasks out in the field, for things like inspections. So, you know, we are developing drone-based inspections of industrial assets, you know, offshore oil and gas platforms, utility plants, rail lines, power plants, things like that. There's a tremendous amount that you can do there to just inspect things more frequently and more thoroughly and more cost effectively. And, you know, we're sort of, I mean, the robotics part of it is really just capturing the data. You know, we think a lot of the value really comes in what you do with that data, you know, having the domain knowledge to be able to take the imagery of the questionable spot on the pipeline and figure out, is that a shadow or is that corrosion? If it's corrosion, what does it mean? What do we do about it? That's really where GE's expertise comes in. And you know, we also have, are working on other kinds of robotic inspection as well, so with crawlers and robotic snakes and things like that. So we see lots of opportunities to use robotics both in factories and also outside of factories in the field.
Just a side question here. How do you determine whether to invest in or to acquire?
That's a great question. So the first thing I'll say is that we are not necessarily investing in companies that we're going to want to acquire. So in the 7 years I've been doing this at GE, I think we've probably had 200 portfolio companies that I've been familiar with. I think we've acquired 3 of them. And there's others that we've tried to acquire and failed. So you know, we don't have the right to acquire these companies when we invest in them. But you know, we're not necessarily investing in companies that GE is going to want to own or that it makes sense for GE to own. You know, we are investing in companies that, because we want to develop a deeper relationship with them, so that we can work more closely with them. It's a great way to ensure that we've got, you know, a close relationship and their full attention on the things that we care about. And we're also investing in companies because it's, you know, we also decide based on the financial return opportunities. You know, we don't need to invest in every company that GE does business with. You know, we're looking for the intersection of what's strategic to GE and what's going to generate a really attractive return on our investment.
It will be same with human does. Okay, before engagement, the marriage, we should do dating with that. Then we can understand who is that, good to fit with us, culturally, technologically, business-wise. Otherwise, it's a kind of gamble, right? That's why the acquisition and the investment is kind of the, how can I say, synergy or kind of the collaborative things for me.
Maybe I'll add to that. So there's really 3 reasons to invest. You know, sometimes you invest to learn, sometimes you invest as part of a partnership, and sometimes you invest as a prelude to a possible acquisition. Often it's more than one of those things, and the rationale changes over time because, you know, what's strategic can change over time. So, you know, you need to be flexible.
Eduardo is from Adept, which was acquired by a Japanese company, Omron.
Right. Omron acquired Adept 2.5 years ago. In the last 2 years, Omron acquired 4 companies here in the US, right? That's what Steve said. You know, you have to look at this, how strategic those companies can be for the company to align with your main direction. I would say that the most difficult part is not the acquisition itself, is often the real integration into the company as a culture, as making sure that you deliver those goals that during the business plan you write down easily in a PowerPoint, but then, you know, there is a lot of effort to make it happen. And regarding Omron, I mean, with Adept has been quite easy, I would say, in a sense, because that was really a piece missing in our portfolio. But when you have, you know, certain overlaps, this becomes more challenging. And sometimes internal issues may affect the final result.
So far, nobody has mentioned big data, 5G, Internet of Things.
I can respond to that if you like. So let me back up a minute and just return to the underlying trends, which are the reason why Eduardo and Chetan are talking about having humans present. There are three big trends that are often lost in the discussion of automation replacing workers. One is mass customization, which we've already talked about, and I'll just give you a picture of how that works. Audi went out with an article a few years ago and talked about how mass customization of the automobiles they make, and they run a multi-model line, which means you might have one model, then another model, then another model, means that up to 20% of their production workers and tooling and work cells are idle at any time. So these are huge investments, right? You're spending many billions of dollars on a new line, and up to 20% of that is idle at any time. That's because you might have say a big vehicle that has a rear air conditioner, and then it's followed by a sedan, and that has no rear air conditioner, so people stand around. Now, what do you want? You want quick tuck times, that's the heartbeat of the production line, and you want the ability to dispatch production labor dynamically across the line, and you want that production labor to really be able to do things that robots can't do. For example, if you install an instrument panel in a car, you do that today with a lift assist device. Somebody pushes that instrument panel with a passive device that's hanging from overhead. And you've got to get that done in 60 seconds or 43 seconds or 70 seconds, depending on the automobile line. And then you've got to go back and get the next one. But those wiring harnesses, the connectors, there are no robots that can do that. A human has to do that. Seeing quality problems that result, catching a process variation from the previous step on the line, only humans can do that. And with these three trends, mass customization, quicker product cycles, and quicker time to market, what you end up with is a need to change the line even more constantly. So the value of human work is actually going up. Productivity, of course, is dollars of output per hour of labor. So that's going up also, and that is often the goal. But remember, that flexibility and that speed to market, all that requires human workers. And until hard AI is solved, and I don't mean just finding pictures of cats, I mean hard AI, until that is solved and all the dexterity problems that Chetan mentioned, you are not going to see human workers in factories replaced. It's not going to happen, certainly in durable goods assembly. So, with that as the background, that drives this revolution that we're talking about, the need and the arrival of new technologies like cheap chipsets to do what used to cost $75,000. For under $100, I can buy a 3D time-of-flight chipset from Infineon or from TI that is much better than the Velodyne LiDAR that used to cost $75,000. I was the first president at Rethink Robotics. It was called Heartland Robotics then. And it was visiting a BMW factory in Spartanburg where I was asked again and again, hey, can your robots be like our big robots, but just help us move this door, help us put this seat in, help us put this instrument panel in. And I would have to say, this generation of collaborative robotics uses power and force limitation. As a result, we're not able to deliver that capability with this generation of robotics. But I had done a human tracking computer vision company before for retailers called Intellivid, and Tyco had bought that. Now, it occurred to me, wouldn't it be great if we could give them the wonderful robots like the ones that are made by Yaskawa that are so durable, that last 100,000 hours and hold sub-millimeter accuracy while moving 100 kilos around constantly. So if we could give that to manufacturing engineers, but just use intelligence and vision to keep people safe, that would be the best of both worlds. The human could provide the judgment. The robots could have the superhuman capabilities that we got robots for in the first place, right? Robots are like draft animals. 10,000 years ago, we had a revolution in agriculture in human history because we suddenly could have water buffaloes pulling a plow. We could have horses that could do things for us. We could ride them and so on. We need big machines to be perceptive of humans and to respond to them in the same way that a big, powerful draft animal, which could be very dangerous, responds to a farmer throughout our history.
Can I just comment on your? So I agree with you, Patrick. But thinking in the revolution, the idea that comes to my mind is instead of exploring the kind of more mature business, you talk about BMW, automotive, where there is already a good understanding of advanced automation. For me, the revolution will come when we are able to see robots in the farm or in in those end user assembling simple product or packing food or fruit. This kind of factory where you find workers with a very low level skill set, right? So I think the challenge that we have is how do we use collaborative robot or even the next generation of solution for that level of basic and very simple automation, where they know what they need, they know how much they can pay for, but they don't have a solution because they are still very complex. All our solutions are really complex to use. So the challenge I think that we have is there a way to use not only robotics, but the industrial automation to teach people? Can we use the data that we collect, answering to your point, right? How do we use this data? It's not just to do predictive maintenance or preventive action. How do we use this data to teach people? Those people will have to find different jobs, right? So I think we have the information, but we don't have yet a good answer to leverage the knowledge of people in the field. And that's an area I like to explore.
Yeah.
So going back to, what is the next revolution in manufacturing with robots? Let's just even take a step further back. Amazon being able to give you an e-commerce platform to sell your goods. What does that mean to big manufacturers, right? Why do I always buy something from big companies? Because they have an end-to-end distribution to go to a store and buy something. What has Amazon enabled small manufacturers to do? Sell worldwide and be competitive, right? Number one. So small manufacturers, in my opinion, will be coming up because of the democratic nature of companies like Amazon. That's one. Second, there's a social revolution going on with Donald Trump being elected in the US. There were a lot of disgruntled people and workers that are fearing their livelihoods, and this is happening all over the world. It's not just in America or Europe, or it's happening in India. It's going to happen everywhere, which means people who work in manufacturing are going to be more concerned about their jobs, and companies that hire them are going to have to pay more attention to their workers and developing that talent. So small businesses, small manufacturers will be more competitive. Workers will be demanding more, and companies will be paying more attention to them. So from my perspective, what do both these two entities need? Workers and small businesses. They all have been using tools. We've been giving workers tools. We've been giving them hammers, screwdrivers, pneumatic air guns, all sorts of tools to make them more productive. Now think of a robot as a tool that you give to your workers so they can use it as an assistant to themselves. It's a highly intelligent tool. It's a highly flexible tool. Who knows what work they are doing than the worker that is actually doing the work? If this worker could actually get this robot off a shelf, deploy it really quickly to assist them and be productive, increase their productivity. This is the ultimate in challenges, right?
This is what the SME group in Europe set up. They had what's called the SME Project, for Small and Medium Enterprise Project. And they determined over a period of years that the workers knew best what they could offload to a machine, to the repetitive part of their job. And they also knew that it had to be short run, plug and play, and super flexible and light enough to be portable and slow enough not to hurt anybody.
And this is how new industrial bases for robots happen. Automotive became a 40% market for industrial robots, not because we targeted them as robot makers. No. They actually started the robot business. They till today understand best how to use a robot to make a car. None of the robot makers do. Okay? So if other companies, let's say appliance maker like GE, starts putting some robots in and your workers are interacting with the robots, you solve one problem, then you solve another problem, and soon you're using enough robots that our robot industry is now responding to appliance makers. So the key is in the user. End user is the key. So how do we make robots that these end user workers will use? It enables us to grow the industry. It also enables us to bypass system integrators, which I know in the first presentation from Nero, the system integrator was a big part of the solution they were targeting. In my opinion, system integrator is the biggest bottleneck for the robotics industry. We go from a $1 billion company to a $20 million system integrator to sell to a $1 billion end customer, right?
On the other hand, you can't have a $1 billion company with specialists in every kind of vertical market there is. I mean, there's chocolate specialists that are integrators that service Hershey. There are food processing integrators.
So we will always have integrators that specialize in application areas.
Right.
That bring an application expertise. But integrators that are just doing automation, I think the end user has a better understanding of their processes, and the day we enable them, you'll see robotics revolution to the next level.
But in a way, you have legacy software and legacy traditions amongst the big robot manufacturers that's slowing down that process.
Yeah, to some extent, you're right.
Actually, I want to say a word for why systems integration remains highly fragmented in industrial automation. I mentioned that I did an earlier company that did computer vision for retailers, and in that space, the systems integrators were all rolled up. So ADT, had something like 60% of the domestic market. And when I started learning more about the channel in industrial automation, there were no players like that. And the reason for that is that so much of what happens in manufacturing doesn't have economies of scale. You can't do it with a punch list. You go into just about any factory in the world and you ask, can I see the tool room? So how many people here know what a tool room is? So I see a few do, and therefore it's a good point to raise. In every factory you go into, there is a machine shop. And what they do in that machine shop is they make their own machines. They make their own hand tools, like for pokayokes, they'll make a go-no-go gauge. They make end effectors. So every factory, and I've been in little sausage-making factories in Buffalo, New York, and I've been in something that's not a factory, Amazon's distribution center in Lexington, Kentucky. Every one of those has a staff of people who make their own machines. Why? Because the process is changing all the time, and you have to solve problems, and you have to solve them quickly. And so what the systems integrator can do is they can bring some of that high-dollar engineering capability on an as-needed basis to solve a problem quickly. And not every manufacturer has the scale to do that themselves. And so, I think systems integrators are fragmented because they are needed because there is so much variability, so much difference between different kinds of manufacturing, as
It
Frank
also
was
came
saying.
from the lack of the standardization. Okay, if the process itself is very standardized, then relatively easier for all of the robot manufacturer to provide best solution for that. But as you mentioned, end effector, it should be very depending on the circumstance, environment of that customer. Customer that might be having their very own philosophy or culture to make some differentiation of the product or quality. This is a little bit tough for the robot maker to cover that area. That's why system integrator could be a supplemental position on that sense.
Go ahead. This has to be the end.
No, that's okay. I actually was going to go back to your original question about big data.
Okay.
Look, I think as we see it, automation, robotics and automation is part of a much bigger transformation. At GE, we call it the brilliant factory, where we're already building complex machines that have sensors and intelligence built into them, where we're using predictive maintenance and other analytics to optimize their performance and so forth. But we're doing that in factories too, and it's not just for being able to make the factory itself more productive, but it's about establishing a digital thread that runs through the whole process, so that connects the design to the sourcing, to the manufacturing, to the operations in the field. So folks probably saw, for example, the news about 2 weeks ago. There was a Airbus jet engine that blew up over Greenland, right? You see that? So that was probably our engine. We make about 2/3 of the engines flying in commercial airliners are ours. So what happened to that? Well, wouldn't you want to know that you could go back and figure out, well, okay, here's the part that failed. Well, which factory was that part made in? Which operators were on that shift? Which machines processed it? Which tools were we using on those machines at the time? How do we trace back the supply chain of the raw materials? Maybe that was the problem. Maybe it was the inspection process. Maybe it was something that was done in maintenance in the field. And having the digital thread of all that data to be able to trace all those things is enormously valuable for us as producers, but also for you guys as consumers. That's really kind of the bigger vision that we're pursuing at GE.
Well, we've run late, and I apologize, but thank you very much.
Thank you.
Thank you.
Thank you.
Thank you.